And in today's episode, among other things, you'll see that world leaders are already visiting robotics companies as if they were visiting strategic bases. We'll also see that swarms of insects and Borgs are being used in military operations. Humanoid robots are going into mass production and are being sold like regular electronics, even on Amazon. In addition, we'll talk about micro-robots capable of moving objects thousands of times larger than themselves, new electric aircraft that promise to change transportation, and nuclear projects that could support human bases on the moon. And as usual, when we put all this together, it's clear. Technology isn't just evolving, it's changing the balance of the world. Let's understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. And there's a technology that's already working in more than 180 countries, and that many Brazilians are already using. It's Nomad, and I'll be straight with you, okay? It helps you stop losing money. Nomad converts your money to the currency of the country you're in, whether that's Brazil or abroad. You open your account in just 5 minutes, get a virtual card, and then a physical one. You can travel, shop online, or subscribe to foreign services with no hidden fees and no surprises at the end. And pay attention to this, okay? Nomad has launched its embedded subscriber identity module chip, which is international and you only activate it when you arrive at your destination. It works on Android and iOS and gives you internet in over 30 countries. And if you're a Nomad PES level, from level 1 to 4, you get 1 gigabyte free at level 5. The internet is unlimited for 15 days and Nomad is giving $20 in cash back to new customers. But it's only for those who open an account right now using the code RI20 on your first exchange transaction. So don't waste any time, my friend. Open your account through the link here in the description or in the pinned comment, or there's even a QR code on your screen. Get your cash back now and stop spending way more than you need to. And of course, you also help Realidade Impressionante keep bringing you the cutting-edge technologies you always love to see. Here, you help me and I help you. Thanks. For a long time when we talked about military robots, the image was always the same. Drones in the sky, armored vehicles on the ground, metallic machines, noisy and invisible. But now, a new generation of technology is emerging. A German startup called Storm Biobotics has announced that it has already developed and deployed swarms of cyborg insects that are programmable, and they are used in real reconnaissance missions by NATO clients, including the German armed forces. Yes, real insects controlled by artificial intelligence. The project uses Madagascar hissing cockroaches, a species known for its resilience and ability to survive in extreme environments. Each insect receives a small technological backpack, equipped with sensors, wireless communication, embedded intelligence, and a bioelectronic interface that is capable of stimulating the animal's nervous system. In practice, this allows for controlling the movement of the cockroach or coordinating dozens of them as an autonomous swarm. The goal, according to the guys, is simple and at the same time quite unsettling: to send these organisms to places where no drone can enter. Tight spaces, destroyed buildings, tunnels, contaminated environments, transit zones, combat areas. Since they are small, silent, and hard to detect, these biological cyborgs can carry out intelligence, surveillance, and reconnaissance missions with a level of discretion that no other conventional machine can achieve. But while technology is turning even insects into war machines, on the other hand, the whole world is rushing to produce robots on an industrial scale, like we've never seen before. Xpeng's Chinese factory is the same one from the controversial presentation, where the humanoid robot's unrealistic walk led many to think it was fake. They announced that they will start in the first quarter of 2026 the construction of a huge production base dedicated exclusively to humanoid robots. The facility will be located in Guangzhou and will cover about 110,000 square meters, a complex capable of controlling the entire life cycle of the robot, from research and testing to large-scale manufacturing. The company describes the project as the industry's first full-chain humanoid robot factory. This means that inside it will be possible to develop the hardware, train the artificial intelligence, validate prototypes, and produce commercial units without relying on external suppliers. And this reveals a problem that the entire industry has already started to notice. Creating artificial intelligence, at least for now, is not the biggest challenge. The real bottleneck is what's called physical artificial intelligence, that is, making a robot work with AI installed directly in it. According to Xpeng, there was a lack of quality training data, a lack of prepared supply chains, and also a lack of industrial processes capable of turning prototypes into reliable products. This new factory was created precisely to solve this problem. The robot that will be produced on this production line is the Iron model, but in its 8th generation. It will be about 1.78 meters tall and weigh 70 kilograms, and a bionic structure designed to mimic the human body, including a kind of artificial spine and layers that simulate the robot's muscles. The processing will be handled by 3 artificial intelligence chips developed by the company itself, which is the Robot 5G powered by A. They also plan to use solid-state batteries, which are lighter and safer, and a multimodal artificial intelligence architecture that combines vision, language, and action in real time. But the most important detail isn't in the specifications. It's in the strategy. XPeng wants to use the same experience they already have in producing electric cars to speed up the manufacturing of humanoid robots, thus avoiding the mistakes that have set the industry back for several years, such as mechanical failures, durability issues, and difficulty scaling up production. The difference is that this time, the product isn't a car, it's a humanoid worker. The first XPeng robots are expected to start working as receptionists and assistants in the company's own showrooms later this year. But the real goal is different. It's mass production by the end of 2026. And if you're one of those who doubt this kind of project, take a look at what's already available for purchase here on Amazon. Check it out. The Chinese company Unitree Robotics has officially put its humanoid robot G1 up for sale here on Amazon's website in the United States, turning a technology that seemed distant into something that can actually be bought with a single click. The model is listed for about $17,990 sold directly by Unitree itself on Amazon's platform. Yes, it is a higher price than on the company's official website, where the G1 costs about $13,500, but the difference has a clear reason: convenience. Buying through Amazon means avoiding complicated imports, international shipping, unexpected fees, and customs bureaucracy. For companies, startups, or even enthusiasts with money to spare, paying more can indeed be the price of convenience. And this detail shows something very important. Only Tree isn't just selling a robot, they're testing the market. The G1 had already appeared previously on Walmart's website for about $21,000, indicating that the company is really experimenting with different sales channels to find out how far the public is willing to go. But the model sold on Amazon isn't exactly the same model used for advanced research. The available version is called, in quotes, without secondary development, which means the user can't freely modify the system or transfer it. It works as a closed product, ready to use, controlled by an app or remote control. Even so, the specifications are still quite impressive. The G1 is about 1.27 meters tall, weighs approximately 35 kilograms, and has 23 degrees of freedom, which allows for relatively complex movements. It uses depth sensors along with 3D LiDAR for navigation, and it can perform pre-programmed routines such as walking, balancing, dancing, or interacting with the environment. The autonomy is around 2 hours per charge, and the torque in the joints is enough for light but very precise physical tasks. Okay, it's not a fully industrial robot, it's not a fully autonomous humanoid, but it's also not a very basic little robot. Ali, it's not an inaccessible prototype. It is already a product available to be added to your shopping cart. But while some robots are getting closer and closer to us, human beings, others are following the opposite path. Instead of large, visible humanoid machines, scientists are creating robots so small that they can only be seen with microscopes. An international group of researchers, led by the Max Planck Institute for Intelligent Systems, the University of Michigan, and Cornell University, have developed swarms of micro-robots that are capable of moving objects up to 45,000 times heavier than themselves. All of this without even touching those objects. Each robot is about 300 micrometers, roughly the size of a grain of sand. Alone, it can hardly do anything, but when they are together, they create something completely new. Instead of pushing or pulling, these micro-robots use fluid torque, which is a hydrodynamic phenomenon where movement in the surrounding liquid generates enough force to manipulate objects at a distance. When exposed to an external magnetic field, the tiny cylinders start to spin, and this spinning creates microscopic vortices in the surrounding fluid. And when dozens or hundreds of them spin at the same time, these currents combine into an extremely powerful collective force. Researchers have managed to spin in drains, move structures, and assemble parts without direct physical contact just by controlling the magnetic field that coordinates the swarm. In one of the tests, the collective was able to rotate a 3-dimensional object that weighed more than 45 times the mass of a single robot. That's it. It's not just impressive. According to the scientists, fluid torque allows for the manipulation of delicate objects that would be impossible to touch with traditional tools, especially at microscopic scales. And that's exactly where the applications start to get really interesting in microfabrication. Swarms like these could assemble very tiny electronic components with extreme precision. In medicine, they could navigate inside the human body, delivering medication, collecting samples, or even performing procedures without surgery. Since these robots don't need to touch the object, they can work in environments where any physical contact would be dangerous or destructive. The experiments also showed that the swarm can reorganize itself, changing formation, altering speed, and adjusting its movement pattern according to the task. This change in scale shows that technology doesn't grow in just one direction. It grows downward, becomes microscopic, but it also grows upward and starts to transform the way we move through the world. And some of these projects are being called flying saucers. China has unveiled what is being described as the world's first electric eVTOL in the 1-ton class with lift ducts. A vehicle shaped like a flying saucer designed to operate in urban environments, flying close to the ground and between buildings. The demonstration took place in Wuhan during an official event related to regional economic planning. In front of authorities and engineers, the aircraft took off vertically, hovered steadily, and performed low-altitude maneuvers, demonstrating precise control and quick response. According to the developers, the vehicle can take off in just 3 seconds, and it was designed to operate in tight urban spaces, where, for example, traditional helicopters would have difficulty. The design uses rotors embedded within the fuselage, thus creating a lift duct system that increases stability, reduces noise, and improves safety. In flights close to the ground, the payload capacity reaches 450 kilograms, and the initial focus is not on transporting passengers and humans, but rather on urban logistics, as well as aerial rescue and emergency operations. The strategy is part of something bigger that China already has, called the low-altitude economy, a sector considered a national priority, which includes drones, electric aircraft, aerial robots, and autonomous transport systems. During the event, 4 different models of electric vertical takeoff and landing were showcased there, reinforcing that the country is indeed accelerating the development of this new industry. According to industry analysts, this could be the decisive year for the transition of eVTOLs from the experimental phase to the commercial phase, with several manufacturers seeking certification for mass production as soon as this year. If this really happens, the way we transport cargo and even ourselves within cities could change completely. And when technology starts to change the Earth, what happens when we take that same technology beyond our planet? Well, the American company Lockheed Martin is working together with National Aeronautics and Space Administration and the United States Department of Energy to develop a nuclear fission system that could be installed. In theory, of course, directly on the surface of the moon. The project is part of a program called Fission Surface Power, or simply Fission Surface Power, and it envisions compact reactors capable of generating between 5 and 10 kilodollars in the first missions. Of course, and with advancements for the near future in systems of 25, 50, and even 100 kilodollars. Okay, I know, it might seem like a little, but in the lunar environment, that's huge, and the reason is simple. On the moon, day and night don't last 24 hours. Each complete cycle takes about 29 Earth days, which means the lunar night can last for 2 whole weeks. The temperature can drop to less than minus 170 degrees, and solar panels simply stop working. In regions near the poles where there is ice and other important resources, some areas remain permanently in shadow. Without a continuous energy source, no permanent base can exist there. And that's why the nuclear solution is back at the center of space plans. A small reactor of 5 to 10 kilodollar would already be enough to keep a habitat warm, charge exploration vehicles, and power life support systems during the lunar night. But the goal goes far beyond that. For an economy to exist outside Earth, it will be necessary to produce oxygen, fuel, and materials directly in space, using only the resources from the moon itself. This requires constant energy. According to Locke, Reed, and Martin, the strategy is to start with smaller systems to reduce risks, and then they will evolve into power grids capable of supporting full industrial operations. Projects like this show that the technological race has become strategic. Today, entire countries compete for leadership in artificial intelligence, robotics, and space exploration. And perhaps the clearest sign of this new era is when world leaders start visiting robot factories, as if they were visiting those power plants or military bases. And this next report shows exactly what is already happening. The German Chancellor Friedrich Merz visited the city of Hangzhou, one of China's main tech hubs, and he made a point of including a stop at Unitree Robotics in his schedule, one of the fastest-growing companies in the humanoid sector. And the visit was not just symbolic. Mertz watched the live demonstrations, including performances by the so-called Woobot, that now traditional martial arts show, using the robots, and even fights between the humanoid robots, used to demonstrate coordination, balance, and dynamic control. During the meeting, the founder of Unitree, Wang Xingxing, presented the system directly to the chancellor, who even examined the robotic components up close, listening to technical explanations about the sensors, actuators, and motion control. But the most important thing wasn't the demonstration itself, it was the context of this story. The visit is part of Mertz's first official trip to China, and he was accompanied by a large delegation with about 30 executives from German companies in the automotive, chemical, pharmaceutical, industrial, and of course, technological sectors. In addition to Unitree, the chancellor also met with representatives from artificial intelligence companies, brain-computer interfaces, electric vehicles, and advanced computing. In other words, this wasn't technological tourism, it was industrial diplomacy. Germany, which is one of the world's greatest engineering powers, is closely watching China's advances in robotics and artificial intelligence. And the reason is clear. The next industrial revolution won't be just digital, it will be physical. Robots, humanoids, autonomous vehicles, embedded AI, neural interfaces, and intelligent systems. They're already beginning to redefine production, logistics, mobility, and even defense. The founder of Unitree himself says that the European market has enormous potential, and international cooperation can accelerate the development of intelligent robotics on a global scale. But behind the nice talk of cooperation, there is also competition. China, the United States, and Europe are racing to lead the next generation of technology. And this time, it's not just about software, it's about machines that walk, manipulate, learn, and work in the real world. The fact that a head of government visits in person challenges society. A robotics company shows that humanoid robots are no longer just an experiment. They have now become a strategic topic. And when politics, industry, and artificial intelligence start to mix, it usually means we're facing a change of era. Yes, my friends, when we look at all this news together, we can see that these are no longer just isolated advances. Robotics, artificial intelligence, nuclear energy, and mobility are already evolving at the same time. And that's it. It's completely changing the way the world works. Machines are starting to take on increasingly complex tasks. Countries treat technology as a strategy for power. And the future seems to be arriving much faster than we were expecting, isn't it? Which of these technologies do you think was the most impressive in this episode? Comment down below. That really helps the video's engagement. If you enjoyed this episode, leave your like and make sure you're subscribed. Thank you for sticking with me until now, and click on one of the 2 suggestions on your screen so we can see each other again in just a bit. All right, thanks. Bye. That big gulp of water at the end because my throat is dry. I sure do talk a lot, huh? Thanks. So, did you like the new set? Is it cool? What needs to change? Leave your feedback right now. Yeah, bye.